So I decided to study the algorithms I have, the programs I have here on stream. And I'm gonna be writing them on this one here, this file here. I don't think the title of the stream updated. So let me see. Oh, looks like it updated now. So I barely looked into this. And it seems like it is written in Python. I have several different programs here that I found from this guy named Robert Miller. I saw a video of him about MAV. And then I started digging through these things, and because I had no idea what it was, and the mempool, the stuff, all this stuff. And then I found out a bunch of repos with these different bots, and I thought it would be interesting to study them. So I started downloading them, and then I created a folder with all of the ones that I downloaded. I didn't get this only from him. I got a bunch from a bunch of different places, I think. So it looks like this is just Solana. This is on Polygon, I think. I think I tried to run this one and didn't work. I don't know why. Maybe this one was made on TypeScript. And obviously Solidity. So I'm gonna start with this one, which seems fairly complicated, to be honest. Start with this file here. Because not only I have to write the methods for Web3, but I think I'm gonna write the methods for Python, because I've briefly looked at this, and there's some stuff I don't understand here. So I'm not really sure if this Azure stuff is some preparation or if it's part of the bot itself. So it's using pandas, numpy. I think I'm gonna install this already because I'm probably gonna use pandas and numpy eventually. Oh, actually not, because I'm not in the directory of my project. I just forgot about that. Yeah. So I'm gonna close this. So I have to search azureml.core. MV futures. The rest here I think is just part of the strategy. So it's not really something I can look up on the documentation. It's just more the way they decided to put. And obviously when I'm studying this, my objective is not copy this stuff here, because it's not gonna work. The idea is to learn from first principles. So try to capture what they done and what their thinking was behind what they did. So I can abstract the principles and search the documentation on my own, try to come up with my own strategies. That's the idea. And I'm also not fixated on arbitrage or the different ways to extract MEV, which I think arbitrage is the main one, but there are also a couple of ones that I'm not even gonna try because I don't agree with the ethics. Arbitrage I think is fine because it's part of the system. And there's also something about liquidations, which is that some protocols allow you to borrow money, and then if the value of the coin decreases to a certain percentage of the money you borrowed, you can be liquidated. So that's another way to make profits of this, as far as I understand. And there are different strategies to this, but I think all these ways are very competitive, and there's a bunch of people already doing them. But I think it's the main benefit of doing things like this, of studying this, is actually understanding the ecosystem and then figuring out what are the problems along the way, so I can potentially find things that I can build to make the system better. And I think that's where the opportunity is, because it's more long term and hard to do. So less people do it. More people are focused on the immediate profits. And everybody that made money, a lot of money from flash loans and bots, were probably doing this for years already. So that's usually how things happen. So you have to start at some point and become involved with whatever you're trying to do. So that's what I'm trying to do here now. So maybe hopefully in 3-4 years, I'm in a better position to take advantage of the next big opportunity, which always comes. There's probably several opportunities right now that me and several other people are not seeing because we are not deep into the ecosystem. Yeah, I want to know what is this TX. Stands for transaction, but where is the first time that it shows up here? So it looks like it's here from MEV library. Get transaction hash. Okay, run context. Get context. Looks like there is some machine learning as well here. I've seen some stuff. I think on the other file. Oh, so here it is. The transaction hash stuff. And it's reading CSV real data set file path. But where are these things coming from? Input data set. Also comes from run get context. Temporary path. What is this? This one. Temporary prefix, current directory. Yeah, I don't really understand that well what they did here. So I think I'm gonna move on to the next file, just so I don't spend a lot of time on a particular one. I just want to get all the information of the stuff that they are using and study that. So supervised, this is the machine learning thing. Report auto ML. Again, this is some stuff. Python and Web3 libs to study. Seems like it's the same logic in the beginning here. Data sets, blah blah blah. Next file. Zoom core again, MV repair, import decoder. And the cool thing about Python is that I know how to study the libraries already. You can just press Ctrl B and I already have some experience of navigating through the code and trying to figure out what happens. Here, well, obviously, not gonna be able to do this because I don't have the libraries. And it just brings me to the init of the project. But later, then I can download the libraries and I'll be able to do that. I'll be right back. So I feel like the beginning is the same thing. Oh, this is the interesting part. I think I stopped here last time. Oh, and I forgot to get the alchemy thing and put it on the env file. But I think what I'm gonna do is put all the RPC things on one file. I always forget that. Need to pass through here first. So it looks like they have a Mongo database and then Etherscan API. Morales, which is pretty much like Alchemy or Infura. Then they have Alchemy and they have sleep time. Another thing that I saw is that Infura limits you for 100,000 requests a day in the free subscription. And I'm not really sure how much that is, if it is enough or not to run something like an arbitrage bot. So that can be a problem. If it is not enough, then I might have to build the whole node thing again and try to get information from my own node. But I think I understand enough at this point in order to be able to do that once I get good with the libraries to communicate with the IPC or RPC, whichever one I'm gonna use. So transaction decoder, DX in transactions. Example, they have should dict. So again, it's reading a CSV, transforming to dictionary, but I don't have access to the CSV that they are reading from. Maybe I should open these files in here. Code, blockchain, bots. I thought I would be able to extract this, but it doesn't look like it. So unfortunately, I don't have I can't know what data they are reading. Oh, they might be from the APIs here. So this decoder is a decoder object, comes from this file. Class decoder. Ah. So I assume this you probably left on a .env file, and that's why it wasn't submitted to the GitHub. But I'm gonna go back to this one. So I go in linear fashion. So he's using this class that he created. Yeah, whatever. Next one. Close this. So Azure ML seems to be a machine learning library. Now he's using supervised auto ML, which is already here, and sklearn preprocessing. So he's using a transformer. Yeah, he's training the machine learning algorithm here. And it probably doesn't have anything. Bing, Grok, parts, and Grok. It's probably PyCharm stuff. I should probably do this on PyCharm actually, since I'm gonna do it with Python. Blah blah, pipeline. Just trying to see if there's anything that I'm missing here that I haven't seen on the other ones. So I think that this was the one that I was working at. Yeah, this file here. Blah blah blah. Yeah, it doesn't look like I'm gonna be able to find information about the Web3 library here. From Jam, Sim, models. Because they probably did the data gathering in another part. Let me put some music here. So it's using the provider, which is the same thing if that contract HTTP provider, or maybe I should write the whole thing. This one I already used, so might not be in Web3, but hooking up to the provider. And this one is interesting. And token is the contract. And maybe estimate cost for transaction. Yeah, but this stuff is not relevant to getting data, because I guess this is a different implementation. Just for the liquidation stuff I was talking about earlier. So I think I'm just gonna go quickly through this. Oh, this one is interesting. It's getting information from the price of Ethereum through the CoinGecko API using Axios. Yeah, I think I'm gonna go through the next one. This one, simple arbitrage, is the one that Robert Miller says that is the hello world version of this kind of stuff, and is the one that I spent the most time looking at, but I still haven't look at it completely. So this seems to be something else that I downloaded for whatever reason. So let's go to the next one. This is more on the Solidity side. Trying to go fast through them because I don't want to spend that much time on this, investigating these bots. I want to spend more time studying the documentation itself. I think I'm gonna be right back. Let's grab some drink. And put some different music. It's kind of hard to find music that is good to concentrate besides classical. It looks like there's a bunch of... Oh yeah, I think Robert also says that you're gonna use a bunch of contracts, and I guess those are contracts from the DEXs or from the decentralized banks that you need to make calls to whenever you're doing this stuff on the solidity parts of the thing. And then he says that you should have a file just for that, so maybe I should do this as well. And looks like this one. I'm gonna copy this file and I'm gonna put it on my project there. So I think it's this. Yeah, poly flash constants addresses. Should open in a different window. So I think I'm also gonna make a folder called constants and put this stuff here. I'll probably want to copy the token as well, because there's probably valuable information there as well. And then I think I'm gonna search on the ETH scanner to see if these addresses are really the ones that it's saying it is here. Just to make sure. So it looks like there are addresses from whales here, which is interesting. Dolovichu pool. I've also been told to not use the router, because this is lower. I definitely shouldn't be doing it in his own stream, but whatever. If I'm really gonna do this, because obviously if I make something that works, people are just gonna copy. But I don't care that much, I think. Okay, so here it's probably the tokens. Interesting. Yeah, no reason not to copy this one as well to my folder here. Even if I'm not gonna use it. Just seems like something useful to have. So it's creating an array of different structures here as an argument. Oh, these are modifiers. And it's an abstract contract, which is a little bit hard to understand. But as far as I can tell, an abstract contract is a contract that allows you to do things with someone else's money. Like, you can pay stuff without using your wallet, let's say. You abstract someone else's wallet with your contract. Something like that. Don't really understand that well, how it works. They also used hard hat. Binance Smart Chain addresses. Maybe I should copy these ones as well. These contracts should be interesting to look at. Uniswap v3. As far as I know, Uniswap v3 is the most difficult one to understand how the algorithm or the mathematical equation for the split of assets work. For Uniswap v1 it's very basic, just a linear equation. The for v3 seems to be more complex. I haven't looked at it though. this is just the interface, the declaration of the functions. Here's probably the logic. Interface. I think with these things, most of the computation is done outside of Solidity in order to save gas. So I guess here's what they would make the loan. It's probably coming from one of these contracts here. A flash loan validation probably. Or high flash loan. This is something. I think it's this one. I think I already looked into these ones. Router. It's using the hard hat libraries. And the dodo, which is probably specific to this case, where they're probably flash loading with the dodo pool. It looks very complicated. Maybe I should write it down. This ethers.get signers and ethers.get contract factory. I think these are just tests to see if the things are working. It's not much that I can extract from here. It also looks very complicated. So I don't want to spend a bunch of time trying to figure out. Another thing that might be worth it just right here is when you swap router dot polygon quick swap. Might be something useful to look at later. Polygon sushi swap. It's probably using Uniswap and other exchanges in these methods. Okay, so utils. Mr. Whale. When I open this .env, and maybe I created this one, so glad I didn't show it. And this is the configuration file where I put the networks. I think I did this one. This process name here. Not the whole file, just the URLs. So I'm going to the other one. I think I'm gonna skip the contracts for now. So it looks like artifacts. Another thing to look at. Pretty sure I wrote this, but looks like I didn't. Got balance. PGA, I think, is just a competition between bots to see who's gonna win the mining bid. Because it's so competitive that there's a bunch of people trying to do it, and then usually the bot that's most efficient, I guess, should be the one that has the transaction mined. And usually the miner gets most of it. And it's highly competitive. No, this one is using an IPC provider. It's using the three of them. But it's still getting from me through Alchemy. Just a lot of files. Yeah, I don't think I'm gonna write this. It seems interesting, but I think it's for the liquidation stuff. I'm not gonna write it down for now because I think I already have a lot of stuff here. I'm gonna be more picky to put other things on the file to study. Block header, I think I've seen on the documentation. Maybe I should write this one down. And then it's using subscribe as well, which I tried to use and it didn't work so well for me. Maybe I should write this Winstone. Yeah. Why not? My only concern is that I lose focus on what I'm trying to do because there's so many things to learn. It's coming from here. They have a list of all the competitors. That's very, very interesting. Yeah, this is definitely a file that is worth putting there to investigate it later. I think I'm gonna put it on constant. because then you get to see the wallets that are doing this stuff. Come on, services. Yeah, maybe if I have these wallets as well, I can probably do something with Python to loop on the wallets and then create a very simple script to get the information from those wallets, the transactions. It's probably possible to do that. Even with Etherscan API, I think it's definitely possible. Windstorm again. I guess this is the same project, so they use this library a lot. It's definitely not easy to build as well. So far all the projects have a bunch of files and looks like people took a long time to build the things. I think I'm gonna go through the one that I already looked into it, which might be the next one. Yeah, I'm gonna skip this one and go to the simple arbitrage. And this is the version thing, the JSON version of the abstract binary interface. And here they also have addresses. I should probably copy this one as well and put it on the same file. I think it's this one. Yeah. Another file with a bunch of addresses. Probably worth it, sure. Copy. Let's see this one. Don't really understand what this one is. Oh, and they also use flashbots, which is, as far as I understand, something that allows you to make transactions without making them public on the mempool. Goes straight to the miners. I didn't understand really well how it works, but I think the point and the solution they provide is for so you don't get front run, which happens when someone sees your transaction and they make the transaction first and they sell to you at a higher price. I think that's the sandwich attack, I think. And the front running is similar to that, where it's pretty much based on speed. And then this flashbots thing helps prevent that to happen by creating some technology that allows you to place a bundle of transactions directly to the miners. But I don't fully understand how it works. So I think I'm gonna write these link parts down from this file because probably important to know. It's hard to know what parts of these projects that people actually coded and what parts they're getting from libraries or from stuff like Hard Hat, where it's coded automatically. I think this stuff I used to think wasn't common when I was doing the Vue.js network exploration stuff, but I've seen this stuff more and more, and I think I'm starting to think that it's just a standard way, maybe that things get parsed when they become libraries. There's probably some program that optimizes the code, and whenever there is a bunch of letters like this, it's probably not people that actually coded. It's probably some library or something, some stuff like that, where you got parsed into this format in the same way that the JavaScript is interpreted into lower level languages and into machine code eventually. I think this kind of code is just a byproduct of some parsing or some stuff like that. But I'm not really 100% sure on that yet. Yeah, these ones look more like someone actually coded. I guess this is just the build, which probably happens after you run or you deploy, when you do hard hat or something like that. At least in React, I think that's how it works. You can do some command and then before you're going to deploy, and then the command puts all the files together in binary code or something like that. And it's npm build. So I assume it's pretty similar here, probably. The cool thing about this one is there is a video that he explains, which I followed, but I didn't really understand exactly how it works. So maybe I should follow this again, watching the video on the side. Just see if I get it. So it creates the objects with the wallets, or the private key, and the flashbot relay. Relay is the thing that connects the what they call searcher, which is the person that is trading, with the miners. So I think I'm gonna close this file and I'm gonna go through the other ones, which might contain the actual stuff. Addresses. Maybe I should copy this one instead of the other one. Instead of this. Or maybe I already have here. I think I'm just gonna replace. So a factory address, I think it is the address that people deploy as a template to create other stuff from, as far as I understand. Yeah, this is probably where the code is at. So an array with if market token address. The semicolon, the two dots is to specify the type. So it takes crossed markets with, which is a type of array with of if market, and token address which is a string, and the type of function is crossed market details or undefined. So it's looking through these crossed markets, which I guess are the markets for the arbitrage. Size of those volumes. Get tokens out with Rust token and Rust sonics. Maybe I should do this for now. Maybe we should focus on getting the data first before I even look at the video again. Just so I don't get sidetracked much. Because sometimes I feel like I should be doing more stuff actively, trying to build the things. I haven't seen so far, at least I've missed, but the part where they get the data, that's the thing. Maybe I just don't understand really well what they're doing, but I guess it's because they're probably not storing the data anymore, like I want to do. They're just running the script that constantly searches for the data, the markets, and finds the opportunity, instead of getting the data somewhere to do the analysis on the data. That's probably the difference. Get Uniswap markets. So it looks like I have to study more the Uniswap documentation as well. I think I remember this part. They say they did it like this should be Pythonic or something like that. And they're searching for the markets here. It says flatting, then group by pair tokens. If pair tokens 0 equals with address, pair tokens 1, otherwise pair tokens 0. Then it's getting all market pairs. Filtering based on the balance to see if it's worth it to even do it. and then returns in a huge list, I think. Markets by token and all market pairs. So I think this is the file that contains the logic for finding, but then they're not storing the data. So it's not so helpful to me because I wanna figure out the API commands to get the data, to get the addresses of transactions. Yeah, because one way to think about it is by only focusing on the exchanges, I think, and the market prices, which is, I think, the way that all these people are doing. And the other way is focusing on the addresses and transactions and trying to capture the relationship between markets on the addresses of people, try to find patterns on the flow of the money based on the information of addresses. And probably the best way is to combine both somehow. So I think that's what I'm trying to do. So you get the data and you get the data, do analysis, and you use these methods here to figure out the opportunity. But I don't think they are storing the data. Unless I'm missing something, but... maybe they are getting the data. Addresses that change. So I think I'm gonna close this, and so I don't waste much time. And I'm going to do this one here. So I stopped on this block number stuff before, which I don't think I'm gonna do this. I think what I'm gonna do is go through the documentation searching for these things here. I'm gonna start first with the Web3 and then I think about the Python, because the first thing I have to focus on is actually getting the data. Then I can think about the machine learning stuff. So I'm gonna put this here. And then I'm gonna search for these methods here. Provider, I already know what it is, because I have there on the file. It's just to set up the RPC endpoint, which is this here. I actually have to see if I'm on the right. Yeah. Is this slightly different than JavaScript, because we don't have the new to create the object, the class instance. Then Web3 if contracts. Yeah, these are all from the TypeScript and JavaScript ones though. So it's probably gonna be slightly different. I think I'll be right back. I'll be right back. So let's see. It doesn't look there is any contract here. Transactions might be interesting though. The problem is you have to specify the address. That's the issue. Transaction hash. I guess the block numbers are linear, so if I start from 0, then I can go through all of them, just like I found on the other question there. So I'm gonna close this. It just seems too complicated to do it. I need to read more on the Ethereum virtual machine to actually understand how it works really well. $200,000, $200 a month. You probably have to create an account. The easiest way is probably choose this API to get the information that I want. Maybe I should set up this just so I don't spend much time trying to get the data. Because I feel like at least in 1 month, doing 100,000 calls a day, that's 3 million. So enough addresses. Then when I have the addresses, I would have to figure out a way to create scripts that can capture the transactions from those addresses. And it looks like it's gonna be very complex. Because I don't know which part I should spend most time on. Instead of the documentation for the exchanges and the other stuff, the smart contracts, or for getting the data. I think I already read this. I understand the concepts, I just don't understand really well how the information, how the machine is stored exactly. Does each block, does each node contain the whole information for the state of the machine, or? Maybe this is what I have to understand better. 'Cause even though I already read stuff about it, I still haven't fully grasped the concept. Yeah, I guess the part I'm having trouble with is this: how does the miner solve the equation for the hashes and how they are connected through the Merkle tree? Deterministic cryptographic hash of a node is used as a pointer to the node. Rather than 64-bit memory location. So it's pretty much a chain of hashes that allows you to figure out where each hash came from by solving the hash you get to the root hash of the node that you're trying to see. But the problem is not that. The problem is where the hash is stored. I think each node contains all the hashes, and each block is one hash with specific nodes. But I'm not 100% sure about that, because then each node has to contain all the transactions as well. If it is the way that I'm thinking. But I think it's more complicated than that because of the internal function thing there. That's what is causing me confusion. Because there are also different types of functions and memory locations. So how are those different types of memory connected in the blockchain in this space of transactions? I think that's the problem I'm having trouble trying to understand. So this might be interesting to read here. All the Merkle trees in Ethereum is a Merkle-Patricia tree. From block header, there are 3 roots from 3 of these trees. State root, transaction root, recipes root. There is one global state tree. It updates over time. In it, a path is always SHA-3 Ethereum address, and the value is always RLP Ethereum account. More specifically, an Ethereum account is a 4-item array of nonce, balance, storage, root, code hash. At this point, it's worth noting that this storage root is the root of another Patricia tree. As where all contract data lives, there is a separate storage tree for each account. To calculate a path in this tree, first understand how Solidity organizes a variable's position. So I guess what's happening when you put the value and you retrieve this way, you're just pretty much solving the hash and finding the root of the Merkle tree for that specific value, because each value is a pointer to the chain of hashes that specifies something. I guess that's how it works. And that's why you have a bunch of nodes doing these computations, which is pretty much verifying the validity of the root of the Merkle tree. Based on the predefined set of rules of the way that the language works, or the blockchain works. It seems it's gonna be a lot harder than I thought it would be to retrieve the data that I actually want. Still don't understand what is this transaction index though, and the RLP over here. I guess this transaction index probably comes on the node. There's so many questions I have. I have to say though, it's pretty genius to actually build this stuff. Let me continue reading the EVM stuff.
Localize the source of the gravitational field. Could this be a Dyson sphere?
So this is the hash of the root node of our Merkle Patricia tree. Or try trees, I don't know how to say that. That encodes the storage contents of the account. A mapping between 256-bit integer values encoded into the tree as a mapping from the Keka 256-bit hash. The bit integer keys to the RLP encoded 256-bit integer values. This tree was the hash of the storage contents of this account and is empty by default. Let me see how to pronounce this. Google.
Merkle Patricia tree.
Merkle Patricia tree.
Merkle Patricia tree.
So it's pretty much a map with public and private keys. Hmm. So that's the thing. Whenever you create an account with MetaMask or other wallets, they actually hold your private key and public key. So if they wanted, they could just get all your funds, I guess. But maybe they have some cryptography on their side, so that in the same way that you have cryptography to store passwords on normal databases, so maybe that's how it works. And actually the address is the thing that contains ethers, which makes sense. And that's why when the contract is payable, it can actually have a balance because it's the same thing. You're just using the address of the function of the contract to withdraw stuff from the contract. And then on the back end, behind the scenes, it just uses this hash thing to verify the logic behind it. So Merkle Patricia storage tree as a words addressable word array associated with the account in question and part of the global state. So when the miners validate, they're solving the hash to find the root of the Merkle Patricia tree, which validates the transactions based on the rule set of the EVM. But it still leaves me with the question of, is it possible to retrieve? It has to be possible. I think in order to retrieve the addresses or both for our accounts and contracts, you have to maybe solve the hash. I'm not really sure about that still. Because it implies that you don't actually need all the other stuff. All you need is the hash and the chain of the hashes in order to verify things, but I'm not 100% confident that all the transactions are stored or if it's just the nonce and the hash of each block. I don't have time to read all of this. That's the issue. So let me go back to the Web3 documentation. So I stopped on this contract, which I assume it doesn't. It's probably a different way to call it from the Python Web3 stuff. Yeah, so I think I can't. To get the internal functions is a lot more complicated, but maybe to get the other stuff is easier. I think I'm gonna search again how to get all addresses from Ethereum using Python. Yeah, I think it was exactly this one. Let me just run this on the background. And I think I'm gonna print the X just to see what it is. Hopefully it works. So the URL is not working. If I do it like this, it's not gonna work as well. Yeah, the issue of doing this and not knowing if it's correct or not is that I'm gonna spend the... Oh, but I think it's 100,000 a day, so even if I spend my limits for the day, it's probably not that big of a deal. It was exactly this thread that I was reading before. So maybe this approach is better. And so this is Web3. Maybe there's something wrong. Yeah, so I think it's combining both. So block number, wow, blue, and all this stuff. And then here, okay. It's outside of here. Oh, wait, why the indentation is messing up? So block dot transactions. And then here I would append them to the CSV. Of course, I have to run to see if it's correct. So I'm gonna search for this as well. But this is in Go, that's the problem. So let me see if there is anything about this. So that's one approach that it's also, you might also be interested to create my own instrumented EVM to extract the data. But obviously it's more difficult then. It's gonna be more difficult. And this seems to be the data that this returns. So I'm gonna put it here as comments. It's probably because of the break there, so put it on top. Yeah, I can create it. So it's gonna return a dictionary. I think there is a way to create data frame out of dictionary in Python. There's definitely a way to do that. And maybe it's better to... first I need to get it once and see. What the fuck is this? I think I'm gonna do this method first because it seems the easiest. So I'm gonna search for how to use environment variables in Python. Probably gonna put this stuff here. I'm gonna try to use this OS instead of this one. Yeah, but the issue is that it doesn't say anything about the actual file and the structure in the folder. So I'm gonna try this one just to see if it works. So I'm pretty sure that's how I wrote it down. This kind of sucks. So let me do this. Positive that I did the right way. I think I'm gonna look it up on how to set up the environment variable with Infura or the HTTP provider. At least no error so far. So this might be because I have to set up the thing. Pretty sure I have the Web3 library. That's exactly what I did here. It looks like it's saying that it refused the connection. So I guess I need to set up something either in Furia or in the terminal to specify that it's actually me that is making the connection. Because I already created an app there and got the URLs and stuff like that. Failure to establish a new connection. Target machine actively refused it. Or I can actually search for this error as well. We'll look at this one next. Yeah, so this doesn't contain the information to solve the issue. So it might be the firewall. So what I think I'm gonna do is actually go read something and then figure out the Furia part, because I don't want to show anything for obvious reasons. I'm gonna enter on my account and I'm gonna explore the Furia stuff to see how to fix this. I can also try with the Alchemy RPC as well. I actually need to remember to put that as well on the env file. So I have both options. And I think I'm gonna try this way first, which seems to be the easiest one. So I'm gonna put this method and I'm gonna see what I get. Then, based on what I get, I'm gonna create a CSV with those columns. And I'm gonna append the rows to the CSV with the information for the blocks. And then once I'm able to do this basic stuff, then I'm gonna probably look into how to create the virtual machine, that is the instrumented virtual machine. And also study more the documentation as well, the Web3 documentation. Because once I have the accounts and the addresses, I wanna do stuff with them. Actually, after I have the addresses, I might start studying the DEXs here. Because I also need to create a list of the contracts. I already have some from the other things there. On the constants here. The tokens, TS. But I definitely need to... I'm gonna create a file just for that to... I'll probably put it in here to get the main functions of these protocols. I'm gonna create a dictionary, I think, with the smart contract address and the functions with the specific address of each function, with an explanation to what it does. Just so I have it so it's more easily accessible. And then once I have all this stuff, then I can start thinking about the logic of the thing that I want to build. I think it might be interesting as well, since I already have experience with PyVis, to actually create a PyVis the same way that I did for the script visualization, but with the data. It might be interesting to see in the graph how that would look like. So yeah, so I'm gonna go eat something and study this inferior stuff. And I actually feel like it. I feel like doing this now, so I'm probably gonna spend a lot of time actually. So after I do that, I'm probably gonna come back today later on. So see ya.